number 27. In right triangle ABC, angle C is the right angle and BC is equal to 162. Point D on side AB is connected by a line segment with point E on side AC such that line segment DE is parallel to side BC and CE is equal to 2AE. What is the length of line segment DE? So there is no diagram given with this, but we can draw our own diagram. So it's given that in triangle ABC, point D on side AB. So first of all, let us mark angle C as the right angle. So this will be our C. And point D on side AB is connected by a line segment with point E on side AC. So if this is A and this is B, so point D on side AB, I will mark D here, is connected by a line segment with point E on side AC. So this is E. It follows that parallel segments DE and BC. So this DE is parallel to BC are intersected by sides AB and AC. So if two parallel segments are intersected by a third segment, the corresponding angles are congruent. Thus, the corresponding angle C, this if it is 90 degrees, angle C, AED in the other one, this is also congruent, that is they are both equal to 90 degrees. And even the corresponding angles B and ADE, these two are also congruent. Thus the corresponding angles C and AD are congruent and corresponding angles B and ADE are congruent. Since triangle ADE, this top triangle, is similar to triangle ABC, that is a full triangle, by the angle-angle similarity postulate, where side DE corresponds to side BC. So DE corresponds to BC, DE corresponds to BC, these two, and side AE corresponds to AC. Since the lengths of corresponding sides in similar triangles are proportional, it follows that DE divided by BC is equal to AE divided by AC. Since point E lies on side AC, this one, AE plus CE is equal to AC. AE plus CE is equal to AC. DE by BC is equal to AE divided by AC. Since point E lies on side AC, AE plus CE is equal to AC. It's given that CE is equal to 2AE. It's already given CE is equal to 2AE. So substituting 2AE for CE in this equation, we will substitute that in this equation. We will get AE plus 2AE is equal to AC. So instead of CE, because CE is equal to twice of 2AE, we are substituting 2AE so that we can add these two. So what that will lead to? It will lead to 3AE is equal to AC. It's also given that BC is equal to 162. So substituting 162 for BC and 3AE for AC, we'll put those value in this proportionality equation. So we will have DE and BC is already given as 162 is equal to AE divided by 3AE. And then we will simplify this. The AE's will cancel out and we will have DE divided by 162 is equal to 1 by 3. Which means after cross multiplication we will have 3DE is equal to 162. Divide both sides by 3. So DE will be equal to 162 divided by 3, which gives 54. So that is what we need. We need the length of the line segment DE. So that means 54 is the